Let's begin our discussion of discrete probability distributions with some background information and some definitions. So discrete probability distributions are constructed by determining the possible outcomes along with the relative frequencies we expect, not what's already happened. So we're looking for the possible outcomes. What are all our possible outcomes? And then what are the relative frequencies of these outcomes that we would expect to see? We want to be able to distinguish between outcomes that are likely to occur by chance and outcomes that are unusual. So we'll have to define what we're looking for unusual, and then the outcomes that, well, that could happen by chance. The probability of occurrence of that outcome is not that unusual, and then we want to be able to distinguish that between those that are. Okay? So let's start with a definition of a random variable x. And this is a variable that has a single numerical value for each outcome of a procedure. Okay? A variable that has a single numerical value for each outcome of a procedure. This value is determined by chance. So let's make a note of that. The value is determined by chance. Okay, so that's a random variable. What's a probability distribution? Well, this is a graph, a table, or formula that gives the probability for each value of the random variable. So a graph, table, or formula that gives the probability for each value of the random variable. So when we're talking about discrete random variables, and we'll talk about this definition in just a moment, but I'll go ahead and say what we're talking about, some examples of these things. Random variables might be the number of people attending a movie, the number of defective light bulbs in a box, the number of people that were called by a telemarketer, something like that. Okay, so that's what we're counting, you know, how many of is in our represent our random variable, and then how many of these. Okay, so let's look at those definitions. Okay, we have a discrete, let's pull that down a little bit, discrete random variable, and you've heard that term before. You've heard we've talked about discrete, and so you're probably thinking, oh, we're going to talk about discrete random variables and continuous random variables, and you would be correct because random variables can be either discrete or continuous. So when we talk about a discrete random variable, we're talking about one that has either a finite number of values or a countable number. Finite number of values. Or a countable number. So these represent counts, right? We said that before when we talked about discrete data. They represent CU, counts. Okay, so again, my suggestion of the number of people called by a telemarketer, number of people who attend a movie, number of defective light bulbs in a box. Remember that key word, number of, that we saw before. Okay, and so discrete random variables are what we'll be dealing with when we work with discrete probability distributions. Okay, but we go ahead and compare that to continuous random variables. This will be our next chapter. But now we have infinitely many values. Infinitely many values. There are no gaps on the scale, so I'll just make a note, no gaps on the scale. So when we say that discrete random variables represent counts, what do we say about continuous random variables? They represent measurements, right? So we will be talking about these later. First we'll begin with our discrete probability distribution, where our random variable are values that represent counts. When we get to the continuous, this is going to be things like heights and weights and volumes of things, right? Things that we measure. Ounces of orange juice in an orange. So there are many examples of these in your textbook, and we've talked about them actually as we've discussed discrete data and continuous data. So we're just continuing with that in our probability distribution discussions. So we'll look at an example of a discrete probability distribution in our next video.